What's up, everyone? Today we're going to talk about Venn diagrams and probabilities, so let's get into it. So Venn diagrams are another way we can represent sample spaces, and how they're usually drawn is you have the universal set, which is represented by a rectangle, and then sets within it are represented by a circle or an oval. So we have the standard Venn diagram where you have one overlapping piece with the two sets in the middle, of the universal set, again, represented by that rectangle. But we're going to look at a couple of different options here as well. First one is when you have subsets. So remember that this symbol represents a subset. So it's saying B is a subset of A, and therefore every element in B is also within A. How we represent that as a Venn diagram is the circle for B is placed fully within the circle for A, which again is always going to be within the universal set rectangle. So let's see an example. We're labeling the Venn diagram for the universal set, which is the integers from 1 through 8. A are the integers 1, 3, 6, 7, and 8. B is the set 3, 6, and 8. So when I do these, especially with subsets, I start with the smallest set. So I'm going to start with B in this case, and B contains 3, 6, and 8. When I go to fill in set A, I know that 3, 6, and 8 have already been used. And since they're within B, which is within A, that's implied that they're in A. So all I need to do for set A is just add in the 1 and the 7. And then you always want to fill in what's left over in your universal set. So within my universal set, I've used, we know 3, 6, and 8 from B and A. I've used 1 and 7 from just A. So that means what's left over is 2, 4, and 5. Our next type of Venn diagram is when you have disjoint or mutually exclusive sets. Don't have any common elements. So therefore, when we represent them in a Venn diagram, the two sets in this case that we're looking at are not overlapping at all. So let's look at an example. All right, we can have the same universal set, the integers from 1 through 8. A in this case is 1, 2, and 3, and B is 5, 6, and 7. So in A, in this case, it doesn't matter what order you go in, but in A, I can do 1, 2, and 3. B, I'll do 5, 6, and 7. And then again, anything left over goes in our universal set. So 4 and 8. And going back to our more traditional Venn diagram, we're going to look at it for two different things. One is the intersection. So we're going to use an upside down U. From geometry, you might have also seen it as an upside down V, but it's read A and B, and it consists of all elements common to both A and B. And this is where, in terms of our diagram, where these circles overlap. So just at that overlapping piece in the middle. Versus the union, which is a U, B, or again, you might have seen it as a V instead of a U, but it's read A or B, and it consists of all elements in both A or B or both. So it's the region that includes both the circles. So looking at both A and B circles together, including the intersection. Example 3, we're being asked to label the Venn diagram for the same universal set. We have set A is 1, 3, 6, and 8, and set B is 2, 3, 4, 5, and 8. So what I'll usually do when figuring these out, so I don't have to do a lot of erasing, is I'll look for what's common in both and start with that, start with my intersection piece. So both sets A and B have a 3, and they both have an 8. So 3 and 8 will go right in the center. Anything that's unique to A will go in the little crescent for A, so 1 and 6. Anything that's unique to B will go in the crescent of B, so 2, 4, and 5. And then again, anything left over needs to go outside of those circles, but inside our rectangle, so 7 goes on the outside. And our final two pieces, first up, the complement, which we've already seen before, but in terms of a Venn diagram, again, remember the complement is denoted with the apostrophe, and it's read not A, and it's consisting of all elements that are not in A, but still within the universal set. And finally, the conditional probability, and this is the tricky one that we're going to see a couple of different times. So the conditional probability, you'll see a line between the two sets that you're looking at, and it's read A given B. and it consists of the elements in A given that B has already occurred. So in other words, you're looking only at B, but what is also in A? So in terms of a Venn diagram, if I'm looking at A given B, I would look at what's in set B, and that would be my denominator for probability, and my numerator would come from the overlap. So this would be my numerator, and the whole B circle is my denominator. And we'll do a couple of examples with that. Example 4, a student is chosen at random from this class, which is represented by the Venn diagram, if E is the event that the student takes environmental systems, G is the event that the student takes geography, and S is the event that the student takes Spanish. We're finding these probabilities and interpreting what they mean. So first up is the probability of E and G, and at the same time, probability of G and E. So the probability that they take environmental systems and geography and environmental systems. They're asking for both because they're both going to be the exact same value. Right? And where we're looking at the overlap of circle, or in this case, oval E with oval G. So we're looking at this piece of our Venn diagram. So 1 out of a total of 2, 4, 7, 8, 11. And I'm going to leave my answers in fraction form for now, but remember, decimal is okay. They are asking for the probabilities. So we do want decimal or fraction, not a percentage. Interpreting what this means there was one student who took both environmental systems and geography. Letter B, we're looking at the probability of E or G and G or E. So again, it's going to be the same thing, which is why they're looping them together, but we're looking at the probability that they took environmental systems or geography or environmental systems. They're going to be the same thing. So that means I'm looking at E or G. So both of these circles together. So basically everyone, including Spanish, since if you notice Spanish is a subset of environmental systems, but we're looking at everyone except these two people on the outside. So that means 9 out of 11 using that complement, or you could just add them up. So that means 9 of these 11 students took environmental systems or geography or both. Part C, we're looking at the probability of not E. So the probability that they did not take environmental systems. So everyone outside of the environmental systems oval. So that means the 2 people that didn't take either or any of these classes, and the 3 people that took only geography. So a total of 5 out of 11 people. So these five people did not take environmental systems. And finally, part D, we're looking at the probability of E given G and G given E. So let's focus on environmental systems given geography first, because these two are going to be different. So when I look at the probability that someone took environmental systems given that they took geography, I'm going to always focus on the given piece first. So this tells me that instead of looking out of all 11 people, I'm only looking out of the people that took geography. So only out of these 4 people that took geography. And out of those 4 people, how many people took environmental systems? Then I'm looking at this overlap. So that 1 out of 4. So what this again means, or how to interpret it, is out of the people that took geography, only 1 person also took environmental systems. And then going the other direction, the probability of geography given environmental systems, they're flipping it on us now. So I'm looking at out of the people that took environmental systems. So out of this E oval, there's a total of 6 people in there. Out of the people who took environmental systems, only 1 also took geography. So all conditional probability does is it kind of limits the scope of the data you're looking at.